For this video, we're going to have a look at some sample questions for 1.12 on HCF, highest common factor, and LCM, lowest common multiple. So these are just a sample of questions taken directly from the assigned Mathspace questions that might help you with some of the concepts. So the first question we'll look at is a reasonably simple one. It's asking us to consider the following prime factorizations. So it's provided two numbers, 180 and 600, and it's provided the prime factors in expanded form for each of those for us. So we don't have to do the factorization. It then says find the highest common factor of 180 and 600. So if we think again, and I'll just bring this over here, if we think again about the highest common factor, that is the two numbers, that is the largest factor of both. Okay, so we've got two numbers, the largest common factor of both, but we have the prime factorization. Remember, this is not all the factors, this is just the prime factors. So we are looking at this second part here where it says that it is the product of the common prime factors between each. So what we need to do is we need to look at both of these lists of prime factors and work out which ones are common. So if I take my sketch for the moment, and this is the way I suggest you do it in your book, that you write them out first. So I'm going to just use the ones that are already here, but I would write them out in my book or my working out paper, and then I'm looking for what is common. So I'm just going to use the top list as the list. It doesn't matter which one you use, but pick one list and work from there. So the first number I'm looking at is a 2. So is there a 2 in the second number? Yes, there is. So I'm going to cross them out, and again, I suggest you do this in your book. And 2 is a common factor, or common prime factor, sorry, so it gets added to the equation that I'm building over here. So I look at the next thing, it is also a 2. So is there another 2 not already crossed out in our second number? Yes, there is. So I'm going to cross them out here, and I'm going to add them to my list of prime factors. I'm now looking at this third one in the top list, and it's a 3. And do I have a 3 in the second list? Yes, I do. It is over here though. So I cross both out to make sure I don't duplicate them, and I'm going to add that to my list of common prime factors. I go again, there's another 3, but I don't have another 3 in the second list, so I can't use that one. So I move on. I've got a 5, and I do have a 5 matching in the second one. So I'm going to cross that out, and I'm going to add it to my list of prime factors that are common. There is still another 5 here, but there's no second 5 in the first number. So this 3 and this 5 can't be used. So the prime factors that are common to 180 and 600 are 2, 2, 3, and 5. Now I could also write this technically as 2 to the power of 2, all right, times 3 times 5. Now that's not required for this question, but it's always good to think about and practice skills that we have. So I could write it in notation form like that. But basically, to find the final answer, to find the highest common factor that's asking for, I simply have to solve this now. So again, I'm going to use my calculator, just bring that into the screen, and I'm simply going to put either of those two equations in. So just clearing it first, so 2 times 2 times 3 times 5, press equals, and I get an answer of 60. So the highest common factor, so I should write that in, HCF, equals, they're my common prime factors, which can also be written in this format, which give me a final answer of 60. So let's put that into the Mathspace and see if we are in fact correct. And there we go, we are. Okay, so let's now have a look at another example. In this one it says, consider the following prime factorizations. And here we have two numbers, 18,375 and 1,575. It says again, find the highest common factor of both numbers. Now, again, it's done the prime factoring for us, but it's easier to work if these prime factors are in expanded form. So the first thing I'm going to do is rewrite these notation ones, or index notations, as extended form. So 3 times 5 to the power of 3, remember, is 5 times 5 times 5. That's what 5 to the power of 3 means. And then I've got 7 to the power of 2, which is really 7 times 7. So that's my first set of prime factorizations in expanded form. The second number here is 3 to the power of 2, which is really 3 times 3. And then it's 5 to the power of 2, which is 5 times 5. And lastly, they've got a times 7. So now I have them in expanded form. And the reason expanded form is a little bit easier because I now can go through and cross them out. Because again, I'm looking for the highest common factor. And again, we know that we can find that by finding the product of the common prime factors if you have a set of prime factors like this. So just like the last question, I can now go through and do it. So I've got a 3 in the top one and a 3 in the bottom one. So I have a 3 here. And I'm just going to actually write HCF here equals, all right. I've got a 5 up here and I've got a 5 down there, so I can include that. So it's times 5. I've got another 5 up the top and another 5 down the bottom, so I can include that one. So that's times 5 again. I've got a 5 up the top, but I don't have another one in the bottom, so that's no good to us. I've got a 7 up the top and I've got a 7 down the bottom, so I'm going to include that. And again, I've got another 7, but I don't have a second 7 in the other list. So the common prime numbers are 3, 5, 5, and 7. Again, just for practice, I'm going to write that in notation form. So 3 times 5 to the power of 2, because I've got a 5 times 5. That looks like an 8 is a 2, sorry. And then times 7. I do want to write that out because if you're looking at this later, you might not realize what I meant. So we'll do that properly. 5 squared, there we go. Again, that doesn't help us now, except for it's always good to practice. But let's work that out. So again, let me bring in my calculator, which I've just lost for the moment. There it is. So let's clear the last equation. And 3 times 5 times 5 times 7 equals 500 and, what was it? Sorry, 525. Okay, so that's my highest common factor of these two very large numbers. So you can see that by having the prime factors and doing it this way, it's going to be a lot simpler than actually writing out all the possible factors of 18,375 plus 1,575. So to do the prime factorization of those numbers would probably be a lot quicker than to actually write out all the factors, and therefore once we've got those prime factors, we can find the highest common factor very, very easily. But again, let's make sure we were correct. So 525 is what we want to enter in here. And there we go, we are correct. Let's try another one. So this one says, find the highest common factor of 42 and 28. So again, it's exactly the same process, but this time they haven't given us the prime factors. So we've got two ways of doing this. We could do our T-charts and find all the factors of 42, all the factors of 28, and then literally find the biggest number in both. But let's again do this by prime factorization. So we're going to this time have to actually do the factorization ourselves. So we'll start with 42. And we're going to break that down into prime factors. So because it is a even number, we know we can always go with 2, and that can always divide by 2, so that'll be 21. 2 is a prime number, so we can't go any further there, but 21 can. So 3 and 7, so 3 times 7 gives you 21. And again, we know 3 is a prime number and 7 is a prime number. So all the prime numbers of 42, or the prime factorization of 42, sorry, is 2 times 3 times 7. So they're the prime factors of 42. All right, so I'll write that up here as well. 42 equals, there we go. Let's do the same thing over the other side for 28. So here we have 28. Break that down. So again, it happens to be a positive. Start again. It happens to be, an even number. So again, we can start with 2 and 14. 2 is a prime number, so we can circle that straight away. 14 again is an even number, so we can break that down to 2 and 7. And again, both of those are prime, so we don't have to go any further. So the prime factorization of 28 equals 2 times 2 times 7. Now remember, I could technically say 2 to the power of 2 because that's what that shows here, but I really want them in expanded form because it's easy to work with. So the highest common factor now, again, is the prime factors that are the same between each list. So here I have a 2 and I have a 2 in the second one. So I can include 2 in my highest common factor. And I'm going to cross them out from my list to make sure I know I've done them. If you've got a second color, it would probably be good to use that if you can. I've got a 3 up the top, but I don't have a 3 at the bottom, so I can't use it. I've got a 7 up the top and a 7 down the bottom, so I'll include that in my list and cross them out. So of course my final highest common factor is 2 times 7 being 14. So did my prime factorization of both numbers, wrote my lists out in expanded form, found the common ones between the two lists, and then used that to calculate my highest common factor. Let's see if we in fact got it correct. So I'm putting in the value 14 here. We will go submit, and there we go, we are correct. Let's move on. This one says, consider the following prime factorization. So again, the numbers 40 and 100 have been prime factorized already for us. This time it says find the lowest common multiple of these. So let's look at our little summary again. The lowest common multiple of any two numbers is the smallest multiple of both. So remember, multiples are just where you multiply by 1, multiply by 2, multiply by 3, or count by that number either way. So multiple of 40 would be 40, 80, 120, 160, 220, and so forth. 100 would be 100, 200, 300, 400, 5. They're the multiples, okay? But mathematically, you can also find it by multiplying one of the numbers, either 40 or 100 in this case, by all the prime factors that are missing from the other list. So let's see how that works. I'm just going to stick this down here so we can keep remembering it, and we'll see how that works. So just like before, I'm looking for what ones are in both lists. So let's say I'm going to work with 40, and I'm going to rewrite them over here to make it clearer. So 40 is equal to 2 times 2 times 2 times 5, and 100 is equal to 2 times 2 times 5 times 5. All right. So in this case, what I want to do is, again, cross out the ones that are the same. But I'm looking for which number I want to start with. So I'm going to work with 40. I'm just indicating that here. So I want to find out which of the values, or the prime values in the 100 list are not in the 40 list. So I've got a 2, which matches the 2, that's fine. I've got a 2 here, which matches the other 2 up there. And I've got a 5, which matches the 5, okay? This 5 here is the number in the other list being the prime, in this case of 100, that is not in my 40 list. Doesn't matter if we've got a 2 here, ignoring that. I'm just looking for this number, the one that is in the other list that I don't have in this one. So the lowest common multiple is equal to the number we're looking at, in this case 40, multiplied by the values, or the prime values, that are not in that list. So it's multiplied by 5 in this case, which of course will give us 40 times 5 is 200. Now I want to try that the other way. This time I'm going to use the red to cross them out. So this time I want to look at 100 as our number we're working with. So this time I'm saying, is there a 2 and 2? Yes, there is. Is there a 2 and 2? Yes, there is. Is there a 5? Yes, there is. Is there a, well, we don't care about this 5 now. Now we're looking at this number here, because we're working with 100 at the moment as a number. So we want to see which factors of 40, which prime factors of 40 are not in our list here. So the prime factor of 40 that is left over that we haven't used in this case is 2. So again, we can say the LCM, if we're using 100, is 100 multiplied by the factor we found, which is 2, which again gives us 200. So we can see that doesn't matter which number we went with, we end up obviously with the same answer being 200. But the important part is pick one number that you're working with, in this case 40 or 100, and find what factors are not being used in the others, what are not common in the other list. So if we're using 40, we're finding what's not common in 100. If we're using 100, we're finding what's not common in the 40, and those will then give you the lowest common multiple. It doesn't always mean it's multiplied by a single number. It might be times 5 times 2 if there are more factors involved. But again, it's the number multiplied by any factors, prime factors, that are not used or are not common, I should say, in the other numbers list. I hope that makes some sense. Again, it is listed in that little, if I can find it again, sorry, I just got to bring that back onto my screen. Yep, so it's listed here. So multiply one number, so one number 40 or 100, by the prime factors that are missing from the list, so the ones that are not common. All right, let's make sure we in fact have got it right, however, so we think it's the number 200, so we put that in, and let's submit. And of course we are correct, well done to us. Let's look at one more. Find the lowest common multiple of 40 and 140. So again, same process, but we haven't been given the prime factor. So again, we're going to have to start by prime factorizing. So 40 is our starting first number. Okay, we can prime factor that again. It is an even number, or it's also a multiple of 10. So we can go with either of those. In fact, I'm going to go 10. So we've got 4 and 10. Now 4 is not a prime number, so let's factorize that further. So 2 and 2. Now both of those are prime, so we can circle them. 10 is not a prime number. We can go 2 and 5. And of course 2 and 5 are also both prime numbers, so we can circle those. So the prime factorization of 40 is equal to 2 times 2 times 2. And again, we could technically write that as 2 to the power of 3 multiplied by 5. But again, I'm going to leave it in this form because the expanded form is easier to work with. If we factorize 140, now I'm going to start this up high because I think we're going to use a few more numbers possibly. Let's again start with a multiple of 10. So 14 and 10. So 14 is not a prime, so let's factorize that. It's going to be 2 and 7. 2 and 7 are both prime, so we can circle those. And we already know 10's not a prime, but it goes down to 2 and 5. And they are both prime, so we can circle those. So actually, there weren't too many more numbers at all. So the prime factors of 140 are equal to, now I'm going to deliberately go straight to these in order. So we should be doing smallest to largest. So I've got a 2 there, multiplied by another 2 here, which again could be 2 to the power of 2, multiplied by 5, and then multiplied by 7. Okay, so they're the prime factors of those. Now, let's again start with the number 40. So we're going to start with a 40. So it's going to be the lowest common multiple is going to be equal to 40 multiplied by whichever factors are not part of that list from 140. So again, I'm going to use red this time. So I've got a 2 here and I've got a 2 over here. So I'm going to cross out those 2. All right. I've got another 2 here and another 2 here, so they can get crossed out. I've got a 2 here, but not a 2 over here, so ignore that one. And I've got a 5 here and a 5 here. But remember, what we're looking for is which numbers from 140, because we're using the 40 to start with, are not being used or not part of the common factors, and that, of course, is the 7. So my answer, or my equation up here is 40 times 7 will give me an answer of 280, and that is the lowest common multiple of both of these numbers. Okay, let's try it the other way around just to see. So LCM, if we use the number 140, okay, and again I'll use a different color to mark them off. So again, I've got a 2 and a 2, they're the same. I've got a 2 and a 2, they're the same. So this doesn't change. I've got a 5 and a 5, they're the same. But this time I'm looking for what numbers are not being used from this list, because I'm using 140 as my starting point. And the numbers not being used is a 2. So again, that becomes 140 times 2, which again gives me still 280. So I can see that it works both ways. If I have my prime factors, I can find which numbers or which prime factors are not being used in the other list and multiply them by the number that I'm looking at, in this case 40 or 140. Let's see again if that, oops, wrong thing, sorry, not what I meant to press. Let's see if that is correct. So we're putting 280 in, and we're going to submit that, and there we go, we got it right. Good on us again. And the last one we're going to look at is a little bit more complex. It is a worded problem, and it's a sort of thing where we can now see how multiples and factors could be actually useful. So let's look at this one. It's going to take a little bit to go through. It is considered a quote-unquote hard question. So it would be in the mastery section, generally speaking, of our class notes or class work, but we're going to have a look at it together. So it says 2 airlines, jet fuel and Lion Air, again the names don't really matter, each land planes at an airport terminal. During the day, jet fuel planes land every 10 minutes and Lion Air planes land every 18 minutes. Now, a shuttle bus takes passengers from the terminal to the city centre, departing every 21 minutes. So we've got three things happening here. A jet fuel plane landing every 10 minutes, Lion Air every 18, and the shuttle bus every 21 minutes. Now, how often does Lion Air plane land and a shuttle bus depart at the same time? So what we're looking for here is multiples. Every 10 minutes, a jet fuel plane lands. Every 18 minutes, a Lion airplane lands, and every 21 minutes, okay, we're looking for a shuttle bus leaves, okay. Now, how often does a Lion airplane land and a shuttle bus depart at the same time? So really we're looking for which is the lowest common multiple, which is the first time after how many minutes, basically from 0 minutes to where it actually happens, do those things happen together. So a Lion airplane and a shuttle bus. So the Lion airplane is every 18 minutes. So let's write that down. I need to get my scribble thing here. So Lion Air is every 18 minutes and a shuttle bus is every 21 minutes. Now I've written those separately because again, I want to get the lowest common multiple of those. And again, I'm going to use this idea here, lowest common multiple, that if I know the prime factors, I can work out mathematically which is the lowest common multiple, okay? So I'm going to first of all prime factor these two numbers. So 18 can be with 2 and 9. Now 2 doesn't go any further, that's a prime number, but 9 is not. That can go down to 3 and 3. And they're both prime, so I can circle those. 21 can go with 7 and 3. Now they're both prime numbers, so we can just close them off straight away. So if I've got my list, 2 times 3 times 3, that is the prime factorization of 18. And the prime factorization of 21 is 3 times 7. And again, I've written it that way because we should be going with our smallest number to our largest number. Let me grab another color. What we're looking for, let's use 18 as our starting point. So the lowest common multiple is equal to 18, because that's what we're going to use as our number. And what ones are common? So we've got a 2 here, but no common 2 there. We've got 3 common here, and a 3 left over, and a 7 left over. So if we're using 18, we want to know which prime numbers are not being used here, and that is the 7. So 18 times 7 will give us an answer. And I actually don't know that off the top of my head, so let's do that in our calculator. So clear the last one. 18 times 7 gives us 126. So we're saying after 126 minutes, there will be a Lion airplane landing and a shuttle bus departing at the same time. So that should be the answer for this first part after 126 minutes. Let's see how we go. Excellent. Now, unfortunately, we've written all over this. That's okay. Which of these two options happens more often in a single day? A Lion airplane lands and a shuttle bus departs at the same time, or a jet fuel plane lands and a shuttle bus. So we basically need to do the same process again, but this time with the jet fuel plane to see how often that happens. And if that number of minutes is less than the one we've just calculated, then it would happen more often. If it's got a bigger number, then obviously it can't happen more often during a day. So we're going to do exactly the same thing, but now with the other value. So let's do this over here. So we can keep everything we've done so far. We already know what the factorizations for the shuttle bus are, because that was the 21 over here. Let's now do the factorization for the 10 minutes. So let's do 10 minutes over here. Factorize that simply down to 2 and 5. Nothing really hard about that. Okay, they're both primes, so we circle them. Let's again write them out. So we're going to do the 21. So we had 3 multiplied by 7. And I'll put the 21 here. And the 10 is equal to 2 multiplied by 5. Now, as it turns out, there are no common prime numbers. There's no 2 in the second one and no 5 in the second one. So if we use 10 as our starting point, let's do that. LCM right, is going to be equal, let's use a 10, so 10. Now there's no 3 and no 7, so we multiply by both, so times 3 and times 7, because both of these are not part of the 10's prime factorization. So again, that same info before, multiply the number, in our case we're going to start with a 10, by all the prime factors that are missing from the other one, so the things that we're not using. Okay, so let's move that out of the way. Let's bring back our calculator. So we have 10 times 3 times 7 gives us an answer of 210. So what we have on this side is how often a jet fuel plane lands and a shuttle bus departs every 210 minutes. And this one that we worked out earlier is how often a Lion airplane lands and a shuttle bus depart. Because the Lion Air is smaller number of minutes, it's basically just over 2 hours, whereas this one is 3 and a bit hours. This obviously can happen more times in a day. Okay, so we can reasonably confidently say, should point out, that a Lion airplane will land more often with a shuttle bus departing at the same time in a single day, and we proved that mathematically. So let's go back and actually choose that option, press submit, and there we go, we are correct. So that is the end of the preview questions. So again, this is a fairly long video, 27 going on 28 minutes maybe, but again, we've gone through in quite a bit of detail 4 or 5 questions here, including a fairly complex seeming question at the end here with these worded questions, but it still just came down to understanding how to do lowest common multiples in this case. So I hope those are useful to you. I would suggest that you might like to have this quote written in your cheat sheet for the test coming up. I would also obviously make sure you know how to use your calculator. And lastly, something I didn't bring into the screen, but I had on the side, to be honest, is I had this list here of the prime numbers, if you like, from 1 to 1,000 technically. So these are all the prime numbers, so I could always double check if I wasn't sure. Now, I will discuss with the other math teachers whether we provide you with a prime number list, either this one or something else similar. We may not need to go this far. Maybe we'll only do the prime numbers up to 100, for example. But we might provide you with a prime number list to help you out as well. Because I don't expect you to memorize this. I probably would expect you to be able to memorize the first ones up to, say, 13, maybe 17, 19. But after that, it starts to get a little bit tricky, and it would literally just be memorizing. It wouldn't be any sort of pattern. So again, yeah, I think we'll probably provide you with some sort of prime number list in the test as well. So there's some resources that you might want to also have handy when you're doing these questions. We will have one of this. In fact, I'll put this particular prime number list on our class page, and you can print out a copy if you'd like to. All right, I'm going to leave it there because it says now gone over 28 minutes for this video, but hopefully these samples help you, especially if you've missed some classes recently.